For what value of r is the sum to infinite terms of the following series is 9 over 4. Let us begin. So here we have a sum. We're going to denote this sum as sum of the infinite terms s infinity, and this series is given by 1 plus 2r plus 3r squared plus 4r cubed, and the number of terms goes on. Now this is an infinite series. However, this series is neither an arithmetic series nor a geometric series because it does not have a common difference nor does it have any common ratio. However, this particular series is composed of two sequences. One will be an arithmetic sequence and the other is going to be a geometric sequence. So if we consider the first term is 1, the second term is 2, the third term is 3, the fourth term is 4. So these are the constant coefficients. These constant terms forms a arithmetic sequence. That means they are going to be in arithmetic progression. And if we consider their coefficient of these constant terms, for the first term we consider 1 only. For the second term we have r. For the third term we have r squared. For the fourth term we have r cubed. Now this sequence is going to be in geometric progression. Now if it is in geometric progression, then it's going to have a fixed common ratio. So the common ratio that's going to be denoted by the letter r in lowercase. Okay, so what we'll do, we'll take this r and we're going to multiply each terms of the infinite sum. We have r multiplied to the first term 1, so that gives us r, but we're going to write it below 2r. Then we're going to take the second term 2r and multiply with r to get 2r squared, and we write it below 3r squared. Similarly, we have 3r squared multiplied with r to give us 3r cubed. Right. Now what we'll do, we're going to perform a subtraction here, such that we get 1 minus r multiplied to sum up to the infinite 2. So this will be equals to 1 added to, so 2r minus r, that's r, added to 3r squared minus 2r squared, so that's simply r squared, added to 4r cubed minus r cubed, that's r cubed, and this goes on. Now here what we have is 1 added to a geometric series. This is an infinite geometric series whose first term is r and the common ratio, that's r. And we know the sum to infinite terms of a geometric series, it has a standard formula given by a over 1 minus r, where a is the first term and r is the common ratio. That means in our case we have r over 1 minus r. And on the left hand side we have 1 minus r multiplied to sum to infinite terms. So s infinity, that's going to be 1 over 1 minus r. Now we're dividing each terms with 1 minus r, added to r divided by 1 minus r whole square. So when we simplify this, simplify means add the two terms on the right hand side. So that's going to give us 1 over 1 minus r whole square. So this is going to be the sum to infinite terms. However, in the problem, we are asked to find out the value of r, and it is given that the sum to infinite terms, that's 9 over 4. That's already given in the problem, that s infinity sum to infinite term, that's 9 over 4. So what we'll do, we're going to substitute s infinity with 9 over 4. So we have 9 over 4 equals to 1 over 1 minus r whole squared. So that's going to give us 1 minus r whole squared equals to 4 over 9. So let's take the positive square root. So that gives us 1 minus r equals to 2 over 3. And solving for the value of r, we have 1 minus 2 thirds. So that means r comes out to be equals to 1 third. Now that means if we consider the common ratio r to be equals to 1 third, then the sum to infinite terms of this infinite series, that's going to be equals to 9 over 4.